Now what we're going to do is to create a portfolio efficiently. And I have to be a little more specific as to what that means. What it doesn't mean is selecting a portfolio like I've talked about before by throwing darts at the Wall Street Journal. Efficient portfolio selection is the type of selection that takes both the expected returns of the securities, the variance of the securities, and the correlations between securities into account to design a portfolio that has the maximum possible expected return and the smallest level of risk. What we're going to do is to design a portfolio that is efficient in the sense of the risk and return trade-off. Now, the lecture notes go into great detail as to how to do this, and I refer you to those notes for the details. I will not talk about actually the mathematical program that's used to solve the efficient frontier problem. We studied the two-asset example in some detail also. In the two-asset example, we went through the various possibilities for correlations and found that if the correlation was greater than -1 and less than 1, then we would get a curve that joined 2 points, and the points would be 100% investment in asset 1 and 100% investment in asset 2. What I'd like to do is to generalize this to many assets. So let's say 1,000 assets. So what we'd like to do is to look at all the different combinations of weights and what they imply for portfolio returns and variances for these 1,000 securities. And this is indeed a complicated problem, because to do this by brute force with two assets is quite simple. We just try different weights and we get different portfolios which imply different expected returns and different variances. For 1,000 securities, the brute force method will not be optimal. But we can think about doing it the brute force way. Trying different combinations of weights. We know for each security the expected return, we know the variance, and we know the covariance between that security and the other 999 securities. All we vary are the weights. And we can think of developing all these possible portfolios. And we think of graphing these portfolios on the usual graph where the y-axis equals the expected return and the x-axis equals the variance or volatility. And as we do our random iteration of the weights, each portfolio represents a dot on this frontier, a particular expected return and a particular variance. And as we continue this exercise, many dots will go onto this graph. The idea of an efficient portfolio is to select amongst all those dots that have a particular level of variance the dot that has the highest possible expected return. And we could also look at it the other way. Amongst all the portfolios that have a fixed level of expected return, we want to select the portfolio with the lowest possible variance. If we do this exercise, we eliminate many of the dots, and we're left with a curve, a parabola, which represent all of the minimum variance portfolios. What we're going to concentrate on are the so-called efficient portfolios. The efficient portfolios are the part of the parabola that is upward sloping, the part of the parabola that for any level of variance you've got the maximum possible expected return, not the smallest possible expected return. This part of the parabola is known as the efficient frontier. And these are the portfolios that we would actually consider investing in. Now, of course, as I mentioned, the brute force method of calculation is not possible. And it turns out that there's a fairly straightforward algorithm for calculating the minimum variance frontier. And I say straightforward, but a number of years ago, I guess it was not that straightforward. And this idea was pioneered by Harry Markowitz in the late 1950s. And this idea, I guess, was rewarded by a Nobel Prize about 4 years ago to Markowitz. So this is no small achievement. And if you think about the economic implications of investors holding optimal portfolios rather than portfolios scattered all over the place, is very substantial. Because you always want the investor to get the best possible trade-off between risk and return. It doesn't make any sense to hold an inefficient portfolio. Why hold a portfolio with 20% variance that is going to earn 10% on average, when you could hold a portfolio that earns 20% on average, that has identical volatility? So the person holding the inefficient portfolio would be throwing away 10% a year. So the economic implications for the economy in general are very substantial. That we always want investors to hold the efficient portfolios. Now this program of Markowitz, which is basically like it's like a linear program that you've solved many times in other courses. And what we do is we minimize the variance of the portfolio for some level of expected return. Or we could cast it in the dual framework where we maximize the expected return for some constraint on what the variance is. We need some additional constraints in our problem, such as the weights in the portfolio must sum to 1. It makes sense that we're going to invest all of our money. So this we could set up, it's like a linear program, but it isn't linear. And let me tell you why it isn't linear. Because the formula for the variance has squared terms in it. And hence, this is called a quadratic program. It works much in the same way as a linear program in terms of the solution, but it's more complex in that it's nonlinear, it's quadratic. Nevertheless, there's many different vendors of software that will give you an efficient frontier. In Excel, you can use the solver program to do the quadratic optimization. And I invite you to visit my efficient frontier program, which is fully scripted in Java on the World Wide Web, where you can select the assets and the frontier will be drawn for you. Now the next question is, which portfolio of the efficient portfolios do you select? And this has to do with the degree of risk aversion of the investor. So we can think that investors have differing tolerances for risk. Some investors have very little tolerance for risk, which implies that they have very high risk aversion. The type of portfolio that they're going to select is a portfolio that has lower variance. Now this does not mean that these investors are going to buy low variance securities or will just invest in something else. It implies that these investors will choose a portfolio on the efficient frontier that has low variance. Within this portfolio might be individual securities that are very volatile. In a global context, this portfolio might include emerging markets, which are extremely volatile. So it's not the volatility of the individual stocks that count, it's the volatility of the portfolio that you've put together. Now there's other investors that will be more tolerant of risk or will have lower risk aversion. These investors will choose efficient portfolios that are more on the side of higher variance. With higher variance, you get higher expected return. So what we need in order to do optimal portfolio selection, we need the expected returns, the variances, and the covariances between all of the individual securities. We also need some measure or some sense of the investor's taste for risk, the risk aversion or the risk tolerance. And this might be as simple as the investor saying, well, I think I could bear like 12% volatility in my portfolio, or standard deviation. That is a comfortable level of risk for me. Well, if that's the case, you tell me 12% is your standard deviation of choice. Then I can go and solve for the unique portfolio that delivers the maximum expected return for a volatility of 12%. And this is how we do portfolio selection quantitatively through the theory of finance using the theory of diversification.